Alright, so question 1 says explain the difference between distance and displacement. So if I have some object, let's say a little beetle on my page here, and it goes for a walk across the page, it might go la-da-da-da-da-da around in circles and any path it wants and go back to the beginning, or go back to some other point. Okay, the distance is the path that the beetle actually walked. Okay, how far did it actually go? The displacement is not the same. The displacement is just the straight line distance between the start and the finish. Okay, displacement. So we can write a proper definition for those two. We can say that the distance is the length of the path travelled, whereas the displacement is the distance in a straight line between the start point and the end point. Alright, the next two questions test whether or not you understand that. Question 2 says that a ball is dropped vertically from 2 meters high and bounces off the ground to half its original height. So here's a diagram of that. The question says at the peak of its bounce, in other words here, A, what distance has it travelled? Okay, so the distance that it's travelled is 2 meters down and then 1 meter up. Okay, so it's travelled a total distance of 3 meters. Question B says, what is its displacement? Well, the straight line distance between where it started and where it finished is only 1 meter. So the answer is 1 meter displacement. Question 3 says a bowling ball is picked up from a ball return and bowled 15 meters through the pins, and then a machine takes the ball and returns it to its starting position. The question says, what is the bowling ball's displacement? Well, the distance between where it started and where it finished is 0. So the displacement of the bowling ball, to answer the question, is 0 meters. So displacement 0 meters. The fact that it went just over 30 meters, that is 15 meters there and then about 15 meters back, is irrelevant because the question didn't ask me for distance, the question asked me for displacement. So the displacement, the difference between the start and finish points, is 0 meters. Question 4 says write out the formulae for working out velocity and acceleration. This is really simple. So velocity is displacement divided by time, remembering that we use s for displacement because d is already taken for distance. Acceleration is the change in velocity over time. Okay, so that little symbol there is the Greek letter delta. It just means the change in something. So in this case it means the change in velocity. So if something was to start at already going 2 meters a second and it went to 6 meters a second, then up here you would write that the change in velocity was 4. If it went from 0 to, 10, then up here you would write, well, that's a change of 10. Okay, so you write the change of velocity for the top section there. Question 5. If a roller coaster ride travels at 12 meters a second for 5 seconds, how far does it go? There's two ways you could do this. The first way is just to talk the question out, and you could go, well, if it's going 12 meters per second, in other words, 12 meters every second, for 5 seconds, then, if it's going 12 meters every second and it does that for 5 seconds, then 12 times 5 is just 60 meters. So that's one way of doing it. You just talk the question out. The other way of doing it is to write the formula. So you would write V equals displacement over time, and then you know what the velocity is, it's 12. The displacement is something you don't know. The time is 5 seconds, and then you just rearrange the formula. So 5 comes over here and becomes a times, and so the displacement is 12 times 5, 60 meters. Doesn't really matter which way you work it out. This way obviously is preferable because it's a little bit more technical, but either way the answer should be the same. Alright, question 6. Question 6 says, suppose you're a passenger in a car stopped at traffic lights, and then it gives a description of what happens to the car over the next 8 seconds. This question confuses a lot of people. If you're confused, draw, when you come into the exam, draw a timeline and go, okay, this is 0, this is 1 second, 2, 3, 4, 5, 6, 7, 8 seconds. All right? The question says, when the light goes green, the car accelerates from rest. In other words, its velocity here, so I'm going to write the velocities. The velocity there was 0. This is time. And it reaches 2 meters a second in the first second. So first second, 2 meters a second. It then continues to accelerate, reaching 8 meters a second by the end of the third second. So here, it's 8 meters a second. The question then says the new velocity is maintained for another 5 seconds. So this 8 is all the way through to the end here. It's always going 8 meters a second from this point to the end. Okay, that kind of gives you an idea of what's going on, right? It starts at rest, it gets to 2 meters a second, then it picks up speed faster and gets to 8 meters a second, and then it maintains that velocity all the way through to the end. So it's not getting faster and not getting slower for those last 5 seconds. Okay, so question A says, what was the acceleration in the first second? All right, well, now that we've got it here, it's kind of easy. So acceleration is the change in velocity over time. All right, so in this case, the change in velocity was from 0 to 2. Okay, so that's a change of 2. 2 minus 0 is 2. And how long did it take? Well, it took 1 second. So 2 take 0 is 2. 2 divided by 1 is 2. Okay, 2 meters per second. Question B says, what was the acceleration here? Okay, so you just do the same thing again. Acceleration is the change in velocity over time. Okay, so in this case, it went from 2 to 8. So 8 take away 2, which is 6. And it did that over what? Another 2 seconds. Okay, so we're only interested in what happened here. From second 1 to second 3, that's 2 seconds. So 6 divided by 2, that's pretty easy. That's 3 meters per second squared. Okay, so pretty straightforward. Question C says, what was the acceleration in the 4th to the 8th seconds? Okay, so what was the acceleration here? Well, if it's going 8 meters a second here, and it's still going 8 meters a second here, it hasn't accelerated, so the acceleration is 0, right? The speed hasn't changed, so the acceleration is 0 meters per second squared. Question 6D says to draw a velocity time and an acceleration time graph for both of those. So we set up our axes. I know that the car's going for 8 seconds, so 1, 2, 3, 4, 5, 6, 7, 8. And I know that the car gets up to 8 meters a second, so 1, 2, 3, 4, 5, 6, 7, 8. Right, so this will be 8 meters a second, and this is 8 seconds. Okay. On the test, this will be started off for you. Okay, all you need to do is finish it. So let me just write these in. Okay, so in the first second, first thing I need to know actually is that it started from rest. All right, so at time 0, it was at rest. Its velocity was 0. All right, after 1 second, it was going at 2 meters a second. 2 meters a second. After the third second, and all of this information is coming straight from the question, at the end of the third second here, okay, how fast is it going? Look at the question, it says 8 meters a second, so you go up to 8, okay, and then it maintains that velocity for the rest of the time, so here. Right, and then all you do is join the dots. So from here to here, here to here, notice that it's steeper because it's accelerating faster, and then maintains that velocity. Okay, and that's the first one done. That's velocity versus time. Okay, velocity versus time. Now we do acceleration versus time. Okay, next video.